All right, let's do another free response. This one is from the calculus test, year 2000, BC free response number 3. Oh, here it is. All right, so the Taylor series about x equals 5 for a certain function f converges to f of x for all x in the interval of convergence, and the nth derivative at x equals 5 is given with all of that. Okay. They want us to find they want us to write the third degree Taylor polynomial for f about x equals 5. Now, before we jump in, we need to clarify some of these numbers. Whenever they say something is about x equals 5, that's your center, and it's normally labeled with the letter a. So you want to change that to a equals 5. Okay. Well, depending on the book that you're using, but most books will use a. So yeah, you need to realize this is not an x value that you plug in. They're centering their approximation at x equals 5. Because look over here, when they ask you to approximate f of 6, this is the number that you're going to be plugging in into your equation. And notice that it's still centered at x equals 5. Okay, so the center, okay, where the Taylor polynomial will be built is on 5, but the approximation is 1 unit away at x equals 6. And this is very, very important to keep in mind. Okay, so how do you write your third degree? Now, third degree simply means to the third power or to the third derivative. Now, if you haven't memorized this already, you have to memorize the Taylor expansion. So Tn of x is equal to f at a plus f at the first derivative at a, x minus a to the first power 1 factorial plus f double, or f, I'll just use 2, the second derivative at a, x minus a to the second power over 2 factorial. And since they want us to do 3 or third degree, we just need one more, plus f3 at a, x minus a to the third over 3 factorial. Okay, and yes, it just continues on, but we only want it up to 3. Okay, so all we have to do now is just basically plug in these guys. This one. The center, since it's at 5, we're going to convert all the a's to 5. Okay, and then when we take the derivative, we're going to plug in 5 and figure out what the value is at that point. Now, you'll notice that they gave you an equation. Now, this one looks very intimidating. And you might be wondering, what in the world is this? Well, they're telling us that you can find the nth derivative, meaning like these guys, first derivative, second derivative. So if you want to find these coefficients, f of a, f prime of a, f double prime of a, just use this equation right here. And notice that the center is at 5 already. So this number n is the number of times you're going to take the derivative. You just have to fill in all the n's with that exact same number. So I'll write it right here. F at 0, no derivative. That's this guy right here. Okay, f at 0. F at 0 would be f at 0 at 5 would be basically negative 1 to the 0 power 0 factorial over 2 to the 0, 0 plus 2. And anything to the 0 power is 1. 0 factorial is 1. 2 to the 0 power is 1. So you basically have 1 times 2, which is equal to 1/2. So this first term right here, and I guess I'll use a different color. Oops. Is 1/2. Okay, so we're done with that one. What about the second derivative, first derivative? The actual first derivative, f prime or f first derivative at 5. And I'm going to bring this, copy this because I didn't want to keep on scrolling up. Right here. Okay, so there it is. Okay, so again, but notice how, interestingly enough, there's no place here that you need to plug in a 5. Okay, so they're defining this as what you're going to get when you center this at 5. So you don't have to worry about plugging in 5 unless in case you're wondering about that. So -1 to the first power, first number 1 to the 1 factorial, 2 to the first, 1 plus 2. And this will equal -1 times 1 over 2 times 3, which is -1 over 6. Okay, so right here we got different color, 1/2 plus or minus 1/6, and I'm going to include the rest now, x minus 5, okay, to the first power. So we're good with that second or the first. This is your first degree, okay. All right, let's take a look at the second degree. We need a second derivative, so f double prime or f2 at 5, which will be -1 squared 2 factorial over 2 squared 2 plus 2, which is basically 1 times 2, 4 times 4, which is cancel, and 1 what? So positive 1/8. So this would be positive 1/8. That's this guy right there. Oops. Erase, please. Oh, there it goes. Okay, and then x minus 5 to the second power. 2 factorial is 2, and that's your denominator. That 2 will be multiplied to 8. So I'll go like this. And, I'll just rewrite the whole thing. Okay, I'm just going to change it right now, okay? So this will become 1 over 16 because of this 2 right here. This 2 factorial. You know what? For the sake of clarity, I'll just leave it alone, and then I'll just write it in simplified form afterwards. Okay, so 1/8 x minus 5 squared times 1 over 2. Okay, and lastly, for f to the third derivative of 5, so this would be -1 to the third power 3 factorial over 2 to the third 3 plus 2, and this will become -1 times 3 times 2 and 8 times 5. So cancel that. So we get -3 over 20. So -3/20th, which will be our third degree. So -3 over 20. And I'm going to include 3 factorial. That's 3 times 2 times 1. So that's times 6. And this will be x minus 5 to the third power. Okay, so if I took all of that and just rewrote it down here, this will look like this. 1/2 minus 1/6 x minus 5 to the first plus 1 over 18 x minus 5 squared. Again, 8 times 2 is 16 there. And then 20 times 6 is 120. So minus 3 over 120 x minus 5 to the third power. And that's your answer for that one. Let me just double check if I got everything right on that one. 3 times 2, yep, 2, 1, 4, 4 times 5, 20, and then multiply that by 3 times 2 on the bottom, so 4 times, wait a second, yeah, so -320 times 3 factorial, which is 6, 3 times 2, yep, 20 times 6 is 120, okay. Now, the next question, when it says here, find the radius of convergence. Let me erase all these. So we're doing this one. Find the radius of convergence. Now, notice that it's not asking for the interval of convergence. It's asking for the radius. Interval would mean from negative some number here to some number there. Radius is just from the center to one end. It can be both ends. That's the radius of convergence. And usually, well, yeah, for radius of convergence, the radius, you don't need to test the endpoint. We just want to know how far you can head off from the center all the way to whatever number this is. So you don't need to go back and test the end number to see if it converges there or not. Okay, now to find the radiuses of convergence, we normally use the ratio test. Okay, and the ratio test looks like this. It's the limit as n goes into infinity of an plus 1 over an less than 1. Now, for those of you who don't really understand the concept of ratio test, an plus 1 is simply the next term in the series. So if you go down infinity, it should get smaller and smaller. If you take the next term, which is smaller than the previous term, and you put it in a fraction, your fraction should be less than 1. And if you add up all of the infinite amount of sequence, because the fractions are getting smaller and smaller and smaller, or the ratios of it, it should be less than 1. So making sure that the ratio of the next term with the previous term is less than 1 ensures that the series will converge. Now, normally for this, notice there's no x value. So whatever you get here, as long as it's less than 1, it'll converge. But if you notice, we have, well, when they ask you the interval of convergence or the radius of convergence, you're going to get an absolute value with an x somewhere in there, and you have to solve for the letter x. And that's going to tell you where it's going to converge. Now, the real question is this, though, and this is the tricky part of this problem. Where is your an? Because once you find your an, you can add on an n plus 1. Where is your an? And so the trick or the trap would be to think, oh, isn't it just this one right over here? And the answer is no. And let me show you why. Okay. Let me move this over because I'm going to need this. Okay. Now up here I put two. You can find this in any textbook under the whole Taylor series illustration. You'll notice that they've defined an for us as this, okay? And you have to memorize this. AK, an, same thing. So, an equals f at n c over n factorial. So if you're looking for an an, this has to fit that format. Now, in this case here, this is including the center at, well, in this case, we're doing it center at 5, right? Okay, and the c is 5 as well. Notice, again, right here, this is your a what? Your an. Okay, so we want to take that and find the ratio, and use, what do you call it? The ratio test. Okay, so where is it? Well, do you notice that it looks a lot like this, but it's missing something? An, according to this, wait, let me just bring this down. So you'll notice that, you have FKC, that looks just like that, right? We need a k factorial or an n factorial. Where is that factorial? Right there. So remember, we're looking for an an. So we need to divide both sides by n factorial, and you'll end up getting this. Fn of 5 divided by n factorial equals -1 to the n over 2 to the n plus 2. And this right here is an. So if that's your an, that is your what? An. But we're still missing something. We forgot to put in the center. Well, how do you put in the center? Easy. Just multiply both sides by x minus 5. X minus 5. Okay, so now our an for to use for our ratio test is this. An equals -1 to the n over 2 to the n plus 2 x minus 5. And so this is our an now, not f of n, f to the nth power, or f to the nth derivative of 5. So this would be the only trick. And again, you would not have known that unless you memorized that this is how the book defines an an in a Taylor series expansion. So you have to make it look just like that. And notice the test makers made it look quite like it, giving you this. But now you realize you have to turn it into this format over k factorial. So you have to bring this underneath right here. Okay. Now from this moment on, you just have to do your ratio test. It's a little bit cumbersome because you have to add on all these an plus 1. So here we go, an plus 1. So negative 1 to the n plus 1, x minus 5. You're only adding the 1 to n's over 2 to the n plus 1, n plus 1 plus 2. Okay, now what I'm going to do is just flip the top, this one, and just multiply it. Okay, I'll just go step by step. So technically you have an plus 1 over an. So that's basically this divided by that. So we're going to write it like this. Negative 1, n plus 1, x minus 5. 2 to the n plus 1, n plus 3. Okay, I'll put n plus 3. We're going to divide that by an, which will be negative 1 to the n, x minus 5 over 2 to the n, n plus 2. Okay, when you divide by a fraction, you multiply by the reciprocal. So negative 1 to the n plus 1, oops, x minus 5 over 2 to the n plus 1, n plus 3 times, or let's just use a dot because there's too many x's. So let's just flip that over to the 2 to the n, 2 plus 2, or n plus 2. That one. Okay. Now it's just a matter of simplifying it. Anytime you have an exponent being added, split it up. So it'll be negative 1 to the n, negative 1 to the first power, x minus 5, 2 to the n times 2 to the first power times n plus 3, 2 to the n plus 2 over negative 1 to the n, x minus 5. And remember, all of this, I forgot to put the absolute value. Okay, we're trying to take the limit of an absolute value of that ratio and make that less than 1. So let's plug it in right here. And we want this to be less than 1. Okay, so this and this cancels out. And then let's see here. And then negative 1 will just be negative 1. 2 to the n will cancel out. And then let's see. Okay, and then x minus 5 will cancel out. Wait, my x should remain somewhere. I don't know where it is now. Do I add in a 1 at recording? I think so. Okay, I made a mistake, and it's very simple to solve. I forgot to put the n right here. Okay, for Taylor series expansion, right over here. This right here, see this? That's your n. Okay, so that's a big problem because if I didn't do that, everything will just kind of cancel out. So let's see here. So this right here will be n plus 1. So let's go back and change this. So we got x minus 5, n plus 1 for that one. And then n, no, not that one here. Where's the x? Oh yeah, this one right here. N. Okay, and n plus 1. Okay, good. So this will be n plus 1. I'm gonna make sure it's not canceled out yet. N. Okay. Phew. All right. So what do we have now? We have. Let me see. So we have negative 1 right here with 2. That's the only constant. So we have negative 1/2. We have the n's, so we have n plus 2 and n plus 3. And then the x's, we have, I'm going to put this in white, so this would be x minus 5 to the n, x minus 5 to the first power over x minus 5 to the n. Those will cancel out. The 1/2 will come out because it's just a constant. It's a negative, but the absolute value of a negative is a positive. So this is going to be 1/2 limit. And if you take the limit of this to infinity, it becomes 1. So that just turns into 1. And what do you have left? We have, well, the limit's gone now because we take the limit of all the n's. And all we have left now is x minus 5. And that has to be less than 1. So we're going to multiply by 2. Good. And this, you can stop here because the absolute value actually means distance. Distance from the center at 5, the distance has to be up to 2. Now, if you put 2 on both sides, you can even do it like this. Negative 2, x minus 5, like that. Add 5 to both sides, you'll get, what, 3 and 7. And if you do a number line, 3 and 7, the middle has to be 5. From 5 to 7, the distance is 2. That's your radius, which again goes all the way right back to this situation. So the radius of convergence is 2. And that answers our question for number letter B. Okay, lastly, we need to show the 6th Taylor series, 6-degree Taylor polynomial for f about x equals 5 approximates f of 6 with an error less than 1/1000th. Okay, so we just need to prove that the error up to the 6th degree is less than 1/1000. Now, we don't know the actual approximation because to find the approximation or the error, we have to subtract it from the actual amount. Does that make sense? So let me show you. How should I do this? So, let me just write out the equation first. So I think this is called the Lagrange error bound. Basically, the absolute value of the whole function. So this will be the complete whole, right? The complete, just the whole thing, minus the Taylor series to the 6th. Okay, do you get that? I know sometimes people will use the letter p because they're polynomials, but basically it's the same thing. Okay, what we're saying is this: if you take the actual amount, I guess maybe we should put the word actual. Okay, the actual amount, if you add up all those infinite terms, and you subtract the first 6 terms of your Taylor series expansion, which is something like this, like including the first one, but 6 degrees, so it'll be like 1, 2, 3, 4, 5, 6, and you added up all of these guys. The Lagrange error bound always says if you do that, it will always be less than the 7th term or the 7th degree. So that's the only way we're going to figure out what this will approximate to. We're going to have, this is the only way to gauge what this is going to become by using the 7th term, meaning the 1 term over. We don't know what this is. We can figure out what this is, but having this itself is not going to help us. This theorem tells us, hey, just find the 7th term and you'll know what this approximation is. It will be less than that guy. So if it's less than that guy, we just have to make sure it's less than 1/1000 and we are done. So all we have to do now is just find the 7th term. So we're going to use this equation again. Let me see if I can copy it over so I can take a look at it. Okay, so we want to find our 7th Taylor series. So again, let's see, f at 7, so it'll be f of 7th at 5 equals -1 to the 7th power, 7 factorial over 2 to the 7th, 7 plus 2, and the center is at x minus 5, okay? Okay, so let's figure this out. This is -1. 7 factorial will be, this will be 7 to the 7th power, actually. Okay. So 7 factorial is huge. So 7 factorial will be, let's see, 7 factorial would be 7, 50, 40 times 50, 40. over 2 to the 7th, which is 128 times 9. And x is basically, let's see, okay, so this right here, as I told you, is x equals 6. So we're going to plug that in. 6 minus 5, and that just turns into 1. So what do we have here? We got negative, so 128 times 9 is 1152, and we got 5040 on the top, and 5040 divided by 1152. Okay, I think I did something wrong here. All right, I figured out what I did wrong. So do you remember this? I told you in the beginning, this is not the actual an. An is when this is divided by n factorial. So we have to actually get rid of that guy or bring it to the left side. Okay, so that's gone. So now this is basically this format here. You see this? Now this is your third term, but if we did it to the 7th, it would be f7 over 7 factorial. Okay, and so that's what we need. And here, let me just start this over. Sorry about that. Okay, so fn of 5, and we need to divide both sides by n factorial, and this would be negative 1 to the n over 2 to the n plus 2. Now we have to add on our center, x minus 5, x minus 5. So finding this is basically the same thing as finding what? Finding that for our 7th term. Okay, so f of 7, 5 over 7 factorial at x minus 5. And by the way, x, again, is this term right over here at x equals 6. That's what we're looking for. So we plug it in, negative 1 to the 7th power, 6 minus 5 over 2 to the 7th, 7 plus 2. And so what do we have? We have negative 7 times 1 over 2 to the 7th power is 128. And you're going to multiply this by 9, so times 9. And you'll notice that this is negative 1 over 1152. Now we're going to use the absolute value of that because the terms, when you compare them, you're comparing the absolute value, the positive number to the 7th term. And this, notice, is going to be less than 1/1000 because the denominator here is bigger. So we verified that that the first 6 terms will be less, the approximation, the error for the first 6 terms is less than 1 over 1152, which obviously will be less than 1/1000. Okay, hope that helps.